We want to solve the given absolute value equation. We have the absolute value of the difference of the absolute value of the quantity 4x minus 1 and 9 equals 2. Recall for the more basic absolute value equation in the form of the absolute value of x equals c, where c is greater than or equal to 0, we set up and solve two equations. We have x equals c or x equals negative c. We'll apply the same idea here, but we'll have to apply it twice, once for the outer absolute value, and then once again for the inner absolute value. So going back to our given equation, let's first consider the outer absolute value. The expression inside the outer absolute value can equal positive 2 or equal negative 2. This gives us the absolute value of the quantity 4x minus 1 minus 9 equals 2, or the absolute value of the quantity 4x minus 1 minus 9 equals negative 2. And now we'll have to take these two equations, isolate the absolute value, and set up two more equations for each of these two equations. Starting on the left, we first add 9 to both sides of the equation to isolate the absolute value. This gives us the absolute value of the quantity 4x minus 1 equals 11. And then on the right again, we add 9 to both sides of the equation, giving us the absolute value of the quantity 4x minus 1 equals 7. Going back to the left, we now set up and solve two equations where we know the quantity inside the absolute value can equal positive 11 or negative 11, giving us the two equations 4x minus 1 equals 11 or 4x minus 1 equals negative 11. Let's go ahead and solve these two equations. On the left, we add 1 to both sides, which gives us 4x equals 12. To solve for x, we divide both sides by 4. Simplifying, we have x equals 3. For the next equation, we add 1 to both sides again. Simplifying, we have 4x equals negative 10. Dividing both sides by 4 and simplifying, we have x equals negative 10 fourths, which simplifies to x equals negative 5 halves, or negative 2.5. And now let's consider the absolute value of the quantity 4x minus 1 equals 7. Again, we set up and solve two equations. The first equation is 4x minus 1 equals 7, or the second equation is 4x minus 1 equals negative 7. And now we solve these two equations. On the left, we add 1 to both sides. This gives us 4x equals 8. Dividing both sides by 4, we have x equals 2. And then for the last equation, again, we add 1 to both sides. Simplifying, we have 4x equals negative 6. Dividing both sides by 4, we have x equals negative 6 fourths, which simplifies to x equals negative 3 halves, or negative 1.5. The given absolute value equation has four solutions: x equals negative 5 halves, negative 3 halves, 2, as well as 3. Before we go, let's check this graphically. To check this graphically, we'll graph the left side of the equation and then the right side of the equation and look for the points of intersection. Using Desmos on the left, we have y equals the absolute value of the difference of the absolute value of the quantity 4x minus 1 and 9. This is graphed in turquoise. And the second equation is y equals 2 for the right side, which is the pink horizontal line. Notice there are 4 points of intersection, indicating we have 4 solutions. The x-coordinates of the points of intersection represent the solutions. Working our way from left to right, we have x equals negative 2.5 or negative 5 halves. We have x equals negative 1.5 or negative 3 halves. We have x equals 2, as well as x equals 3. The graph verifies our solutions are correct. I hope you found this helpful.